Hello and welcome everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Shresh Sahu, part of the data science team at Analytics Vidhya, and I will be the moderator for this session. For those who have just joined us for the very first time, a brief introduction about the DataHour sessions. The DataHour is a series of sessions conducted by Analytics Vidhya, led by top industry experts. It's a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests itself, it's 1 hour dedicated to data. Now on to our today's session, which is building AI application in minutes. And these applications can use text, audio, images, and more. So in this data hour, we are going to build some of these live. Also, you will be provided with Google Collab notebooks, so you can build these applications live during the session. Now on to our speaker. In this session of DataHour, we have Rajiv Shah with us. Rajiv Shah is a machine learning engineer at Hugging Face, where his primary focus is on enabling teams to achieve success with AI. Previously, he led data science enablement efforts across hundreds of data scientists at DataRobot. He was also a part of data science teams at Snorkel AI, Caterpillar, and State Farm. Rajiv is a widely recognized speaker on AI, had published research papers, and received patents in many domains, including sports analytics, deep learning, and interpretability. He received a PhD and a JD from the University of Illinois at Urbana-Champaign, which is really fantastic. Over to you, Rajiv. The virtual stage is all yours.
All right. Thank you so much. I like that you put the word fun in there because I want this to be kind of a fun experience for people as well. So let's get started. The one thing I would ask people to do, because I would like you to be active and participate in this, is I've shared a Collab notebook. So this is an online Python notebook that you're going to be able to code in real time as we go through this. So if you can please click on the link, open up the notebook. I'm hoping you can see my page here and see the kind of a Collab notebook here. What you want to do is make sure you connect and have a Collab notebook that's running. And then to save time, to make things easier, I would just like you to go ahead and click Run All and just run the entire notebook while I'm talking. So when we come back later to the notebook, we're going to be able to see that as well. All right. Okay. I saw, is there any, okay, yes, the link will be posted in the chat. I've got it here on the slide. If you could kind of copy it down that way as well. I'm going to trust our fellow people in the chat to help me out here with this. I'm going to pause every 20 minutes or so and try to take some questions. So feel free to ask questions as we're going to go through this. I like to make these a lot more interactive and fun because after all, you're spending the time being here live. I want to make this enjoyable for you as well. So let's jump into this. If we look at kind of what's happened in AI over the last just couple of years, there's just been a lot of radical developments, and some of these we don't even understand. And one of these is search. Now, I remember when search engines were largely keyword-based, right? Lexical, where if you didn't type in the exact word, the search result wouldn't come back and understand that. Right? The world has changed. One of the things you see now is what's called a semantic search, where when you do a search, it understands the context of what you're asking. It knows if you ask what or how many, that you're looking for different things. If you use a term like great or good, it recognizes that those things are similar to each other. Now, this type of semantic search is powered by, as we'll talk about, kind of these transformer engines and these pre-trained models, but it's really something that's radically made search a lot better. And it's actually one of the things that when I work with enterprise data scientists, this is something that they're all kind of code and add into their own websites, into their own internal search engines as well. Some of the other cool things that we've seen in the last few years is auto-completion. Okay, and remember, we all remember the early auto-completion fails with things like the iPhone, but it's gotten a lot better. Like I can tell you, when I use Gmail, like I'm always tabbing over and doing that. And you even see kind of auto-completion now in many other domains. You see GitHub's Copilot, where people are now coding and using this autocomplete. So it's another technology that we're seeing all over the place. Other things that have just radically transformed is translation. There was a time when it seemed like we would never get close to human translations with any type of approach. But with the power of enormous amounts of data, using these complex models, translation has continued to improve, and it's amazing. And we're going to actually use some of those translation products today as well. And I talked so far about text, but this isn't just limited to text. If you look at innovations, for example, what Tesla has done for automated driving, theirs isn't perfect yet, but it is amazing how much they can do in terms of detecting objects, right? Who's walking, who's there, keeping track of different cars, all of that in kind of the visual spectrum. These are all technologies that are powered by transformers, using techniques like object detection. All of this stuff is cutting edge stuff, just come out the last few years. Amazing technologies. Now, what I want to show you today is that anyone can use these technologies. You're going to be able to kind of, during this kind of hour session, is I want to show you how you can use a lot of these technologies that are available off the shelf, but are still providing state-of-the-art performance to be able to use and do that. All right, so how are we going to do that? Let me show you kind of how we're going to do that today. We're going to actually translate this and build a specific application. And the application I want to build today is, if I get a picture, I want to be able to identify what kind of food's in it, right? Identify, hey, this is a samosa here. And then I'm going to take that word, whatever the food it is, and translate that into some other type of language. So Arabic, whatever other language. This is a pretty cool kind of application. And I want to show you how we can build this together today, taking advantage of all these technologies. Now, some of you might be thinking back, like, wait a minute, right? Maybe you're early into your AI, maybe you haven't seen AI. Like, come on, are you really going to be able to do something like this? I mean, isn't AI supposed to be difficult? Aren't you supposed to spend years kind of learning all these different tools before you can start doing any machine learning and AI? And I think this is where sometimes how we teach data science is a little bit of a disservice. Because if your goal is to be kind of a PhD researcher that's designing and building the cutting edge stuff and just using it from scratch, well, yeah, maybe you do need to learn a lot of this stuff. And that's where you go get a PhD and spend many years doing it. But here's the thing. We can still take advantage of these tools. We're able to take advantage of these tools without having to understand all of these pieces. And what I want to show you is how we can be a consumer of these technologies and being able to do all this. Now, in order to do this, we're going to take advantage of things like transformer models, the latest kind of hottest neural network architecture that's allowing us to build this. We're going to use that transformer library that allows us to give us a package of instructions of how to do this. And I'll show you how we're going to use the Hugging Face Public Hub to grab lots of pre-trained pieces along the way to do this. And what we're going to do here in the next hour is we're going to build this fun little Indian food detector. And I'll kind of even show you exactly kind of what we're building. There's a link inside the notebook for kind of how to build it. But it's going to essentially be able to take an image like this. Hey, what's in this? I'm going to ask it to recognize the image. It's going to say, hey, this is fried rice. And then I'll be able to go down, pick a different language that I want to translate it into, and then the translation will run to do this. All right. I see questions in chats and things like that, so I'm looking over real quick to see if there's anything there, how to do. Okay, just somebody interrupt me if I need to answer any of those questions. Otherwise, I'm going to keep going on this. So let's get back into this. Hopefully I've motivated you with kind of this interesting project that we can build out here over the next hour. Now, if you talk to data science, if you talk to how most data science is done today, let's talk about the traditional approaches, is if we want to use machine learning, right, with the idea that we want the computer to learn the patterns to help us investigate what's going on, what we need to do is first go out and collect some data. So I like this example. This is if we want to predict the sales price of houses. One thing we might do is go out and collect, hey, you know, this house sold for this much money at this square footage. Let's go get some more data. Oh, here's a couple of more pieces of data. Now I can start to see a relationship here between as square footage increases, sales price increases. I can get more data. And this is what traditional machine learning does, is we collect lots of data, and then we use the machine to help infer exactly what that relationship is here. And in this case, you'll see this line is a machine learning model. Right? It kind of minimizes the error of all my observations and helps me understand, you know, what the relationship is here, in this case, between square footage and sales price. And the value of a model is once I've built this machine learning model, if some new house comes along that I want to be able to estimate the sales price, all I need to do is say, tell me what the square footage is. If I know the square footage, I can give you an estimate on the sales price. This is how we use machine learning models all the time to help us make decisions for things that we don't know about based off that past experience. Now, the problem with this is, right, this is great if I want to be able to find houses in Chicago, and the next house in Chicago, I could use this model. But let's say I want to move to Mexico City. Am I going to be able to use this model there? Or am I going to have to go back out and be like, oh, I have to now go out and collect a lot more data. I have to label all that data, right? Find out identify the sales price of it, engineer the features, do the calculations, figure out all the different variables or features that I have, train the algorithm, evaluate it, and test it. Right? This is a long process. And this is why machine learning often takes kind of weeks to months for most teams to build, because it's a lot of kind of legwork that you have to do to build out all of this stuff. There's no quick, easy way to do this with this approach. And so that's kind of the traditional approach. But what I want to show today and have you take advantage of is pre-trained models. And pre-trained are exactly what they say. They've already been trained for a specific task. And because they've already been trained, all we need to do is say, hey, give me a prediction, and it can give us a prediction. We don't need to go through this long process of data prep and labeling. And this is why pre-trained models have gained so much traction, is because they can dramatically decrease the amount of time it takes to be able to put a model into production, as well as providing kind of a large amount of accuracy. All right. If you haven't received the code, take a look inside the chat, or maybe somebody will share that with you for kind of where the notebook is as well. And just, I know there was a question here, so I just want to make sure I hit it really quickly. I'll just take a quick second here. Is if you want to run the entire notebook, if you go up over here into runtime, run all, that should run the entire notebook contents for you as well. I don't like to leave people behind, so hopefully that interruption is okay. All right. So yes, transfer learning, pre-trained models. Now, what are these pre-trained models? I want to just highlight for people that are new, just some of the kind of characteristics of these pre-trained models as we get into it. These pre-trained models are models that are trained for specific tasks that are typically trained on enormous data sets. In that Chicago example, I might have built a model on 100 examples of houses. But these pre-trained models that we're going to use are built on millions of examples. Some of them can be built on terabytes of data. So just enormous amounts of data sets. these models often contain millions to billions of parameters. And you can think of this as like the brain capacity of the models. These models have the ability to really kind of think and granularly look and shift through data. And that's why they understand, right? What's the difference between kind of great and good and how they're similar is because they have so much information and can recognize the relationships there. The trade-off, right? There's always a trade-off, is these models take a long time to train. They can literally take days, weeks, even months to train. There's enormous GPU clusters. It can take tens of thousands of dollars to millions of dollars to train them. A lot of the most cutting edge language models there are, corporations hide them and hold on to them and don't publicly share them, simply because they're multi-million-dollar resources that gives them an edge over others. And so this has been actually a big friction point inside the data science community, is having access to that. For those of you interested in thinking about that, if you look at the Bloom model that Hugging Face has spent the last 3 or 4 months developing, is an open source kind of pre-trained model. But most of these pre-trained models are hidden behind kind of corporate models, corporate walls, once we get to the biggest models. Okay, so let's go and explore some of this. I spent a bunch of time talking. Let's actually kind of have you spend a few minutes kind of clicking through and starting to learn this stuff. The starting point I like to use is Hugging Face has a page designed to help you understand some of the most common pre-trained models that you can start using. And this is right here at the location, hf.co/tasks. I'm going to go over here, and if you just go to the Hugging Face website, and in this drop down over here, you'll see the word tasks, and we're going to start there. You can also simply just type in the word tasks up here as well. The tasks here is Hugging Face has taken the time to go ahead and talk about some of the most common things we use pre-trained models for and lay them out and explain them very nicely. So I think it's a great starting point. I still use it on a regular basis. So you can see here we have ones for natural language processing, working with text, audio, and computer vision. Let's start by looking at the audio, automatic speech recognition. Okay. So automatic speech recognition is how we take speech and convert it into text. And again, this is something that technology that has existed for a while. But if you wanted to do this 10 or 15 years ago, it took an enormous amount of hardware and special resources and software modules and all of this to do this. What I want to show you is that we can use Hugging Face tasks to be able to do this. And the task to your input tells you what you need for the input and what's the output. But my favorite thing is this little widget. Because with this little widget, I can try out the model for myself. I recorded that, and now let's go ahead and compute it. And you can see here, just in real time on this task page, and you can have it talk however you want and see how well it works for you. But what we're doing here is literally sending an audio input. There's just a pre-trained model that's taking that input and then outputting out the text. So this is, for me, it's a little bit like magic. I'll show you later how we can code this up. But for now, I just want you to understand, what are the building blocks here? What are the things that we can start doing kind of in a very easy way that is provided for us? The task page has lots more details. There's Omar has a video if you want to learn a bit more about speech recognition. You'll see there's links to the models, the data sets. We'll explore this as we go on, kind of code for how we can start using all of this right away as well. But I like to inspire people, so let's take a look at kind of one more task as well. So I could literally, if I had time, I'd spend all day walking with you through this stuff like this. Okay, All right. Let's look at object detection here. I see some things about Collab Notebook. Somebody will have to speak up if can, is the Collab working for anybody? Can somebody just thumbs up and say it's working for me? So that way I know that, yes. Okay, thank you. Okay, so people will figure it out. Thank you. All right, object detection. Object detection is another very cool thing where we can take an input of an image, identifies not only the object, but where the object is inside there. Again, there's pre-trained models that we can use this with. If you have your own image file on your computer, you can feel free, drag it in, see how well it works. I can go in here, I could type in Savannah here, see how well this works, and you can see it identifies, in this case, some zebras and giraffes in the picture as well. If you want to learn more about object detection, again, there's lots of resources here. So I want you to think of these tasks as a great starting point. If you're not familiar with these tasks, spend some time. I think this is kind of basic stuff that anybody in data science should be aware of, what types of models are easily available to kind of be out there and start using them. And take advantage of these nice little widgets here to be able to kind of play with it and, try your own, upload your own crazy stuff in here and see what happens, right? Like you're like detected 2 cups, right? The little bit of there, Bonnie got it on there. Okay, so that's tasks. All right, good, it's working for people. Let's keep going. I got a lot of stuff I want to cover here. So I like to think of all these different tasks as the building blocks of modern AI. And this is why I like people to be introduced and just for you to be nowhere. Now, as a data scientist, I teach data scientists that you should always understand the problem that you're solving and pick the tools to solve the problem that you're solving. And yes, that's how expert data scientists work with problems. But if you're new to data science or you don't really understand all the tools out there, I think it's important to first go out and learn all the different tools out there. Once you have a better understanding of these are the tools that are out there, then you can help figure out which ones to apply to particular problems as well. Okay. Oh, there's lots of good questions. All right, we'll stop for questions here in a second. So next, I want to say is I've shown you how to do this in the browser, but browsers are limited, right? To use technologies to make them work inside an enterprise, you have to code. So we're going to take advantage of the Transformers library. Transformers library is enormously popular. It's much more popular. It's grown very fast. And the reason it's grown really fast is because it allows you to do all this really cool stuff with very few lines of code. But on the other hand, if you're an expert and you want to dive in deeper, you can go and look at the Transformers code. You can also take advantage of the other adjacent libraries there are, like Accelerator, Optimum, to further accelerate how you're going to build out your code as well. So let's jump into it. I'm going to go ahead and just take a second here and look at some of these questions and see if there's 1 or 2 kind of easy questions that I can ask. So let's talk. There's questions about using pre-trained models and how we can use them. Can you use them for your own research or not? And when we get to looking at the pre-trained models in the notebook, I'll hit those again. Sorry, I'm going to answer those questions. Yes. Okay, so let's open up the notebook for everybody. And hopefully things are running okay. I think it's running for some people. So let's go ahead and run the notebook. If you haven't done runtime run all, you can do it now, or you can kind of wait to do this and do this along. I've tried to put in here links to a lot of the things I've talked about, like the Hugging Face tasks, the speech recognition as well. I keep getting these things about people raising their hand, but I'm not sure what I can do. I see the chats flying by. So if people put it in the chat or the question and answer, I'll see it that way. So the first thing I want to highlight is there's the pipeline functionality in transformers. And what pipeline does is it gives you an easy way to take advantage of a lot of these tasks where it defines a specific input. And for that specific input with the pipeline, you'll get an output like that. So let's go ahead and look at the first example here I have in the notebook. This is a sentiment analysis. And we're going to take advantage of the transformers. We're going to import in the pipeline. And then I'm going to set this pipeline and say, I want to use it for sentiment analysis. Now, once I've created this pipeline object, all I have to do now is just pass some text into it, and I'm able to use it. So you can see here, I wrote, I was pretty unhappy with the sneakers. I got a label of a negative score. Hey, if I change this up and say, hey, let me see if I'm happy with the sneakers, we can go through. Now, sentiment just helps us understand, is this particular sentence, is it something that's, happy and positive, or is it something that's, sad, complaining, and negative? I see a lot of sentiment analysis used by folks in customer support. You can imagine if you have lots of emails or tweets coming at you, you might want to prioritize which ones are those are the most grumpiest and either answer them or give them to the one specialty person on the organization that can deal with all of that stuff like that. But this sentiment analysis is a very popular way of getting a sense of learning this stuff. Okay. Now, when we use sentiment analysis, you'll see I didn't specify a particular model here. And that's because the Hugging Face has already picked a default model to use. If I click on this link, I am going to go to the specific model card here that tells me about this model. Now, one of the things it will tell you is the license. I know there were some questions about, hey, can I use this for my PhD? Can I use this for my work? All of this will depend based on the license for the particular model. There are some licenses that are like Apache 2.0 that are free to use for any use for commercial use. But there's other models, and I'll show you with the Facebook one later, that are, for example, only allowed for non-commercial use. So as a PhD student, you could use it. But if you were starting up a business, you would not be able to use that as well. All right. And I see some things about kind of compute and taking into account. One of the reasons I picked Google Collab is because the Google Collab has the compute resources to be able to kind of do this, and you don't have to rely on your local computer. All right, let's do a couple more fun examples. We talked about that auto completion. This is a text generation pipeline that it will keep generating text after some initial text. So you can see in this one example here, I put, in this course, we will teach you how to, and you'll see it generated how to find a way to make the most of your gift ideas like that, right? Like I have another fun example here that I like to do is, imagine you're going to use this to tell nighttime stories. What kind of nighttime stories is it going to use? And you can see here, if you want to influence on it, it's using the GPT-2 model for text generation as well. And I think one of the things that comes up often is a lot of these large pre-trained models are very large, and sometimes it can take a long time to do predictions as well. So one of the things is when you're starting to use these in kind of commercial purposes or for, depending on your size, your data, these are considerations that you're going to have to take into account. All right. Okay. It looks like in this one, I got a God one here. Once upon a time, they were giving it to him. Must have picked up on the Bible in this particular case. All right. I'm hoping this is inspiring you a little bit. Let's take a look at an image classification example. And here we're going to take a look at this image. So I can grab this image and just show it to you. It looks like a big fat cat, right? No data science presentation is okay without a cat picture. But once we put it kind of through our detector here, you can see it actually detects it as a lynx. And when I looked up lynx, it kind of made a sense. But you can see here how you could take any image and automatically figure out kind of what categorization it is using this kind of vision transformer base model here as well. So again, lots of things you can take advantage of these pre-trained models to do. The last example I want to give here is a translation model. So this is a translation model, and I gotta go ahead and kind of pull up the model card again for this particular model. This model was just released by Facebook Meta last week. It's state-of-the-art translation model. Inside its paper, it even compares itself to Google Translate. And this is a model that's really was designed to encompass a wide variety of languages. It has over 200 languages that you can translate between. Now, they've put this up there. Now, this is the license here you can see is different. This is a non-commercial license. So we can use this like we're doing for kind of research, education, but you can't build a business based on this particular model out there. Now, this model is very cool. As you can see here, we were able to kind of translate this particular sentence here between English, Latin, and kind of, I don't know, Syrian. But if we want to translate this into another language, if I want to translate this, let's say, into Gujarati, I can put in here what the target language is, and I'll kind of rerun that, give it a second to run, and I'll be able to see that. All right, come on. Things never go as fast as you want them here. Okay, let me answer some of the questions. I know there's some questions around hyperparameter tuning and fine tuning. I'm going to talk about that. You're kind of getting ahead of me a little bit on that. So far, we're just using off-the-shelf pre-trained models to do things. And here you can see, here's our translation into Gujarati. Unfortunately, I can't tell you if that's right. All right. So that's just using off-the-shelf kind of pipeline and pre-trained models. Now, as we go through this, one of the things you'll notice here in this Hugging Face Hub, there's a lot of models here. And this is where I want to introduce people to the idea of transfer learning. I know some of the folks in the chat have already picked this up. But one of the things that was kind of discovered, or just, I don't know, one of the things that came to light in the last 10 years or so is this idea that I might take a very large model. For example, this top model, I trained it on ImageNet, which has 1,000 different classes. So it has like ducks and chairs and cars and cats and dogs. And this model gets really good at telling these 1,000 different classes apart. But what I can do is, because it's learned so much about just how to visually see objects, if I'm training a model for something else, let's say to identify ships, it can take a bunch of that knowledge, right? Maybe it understands like the concept of water and kind of objects that float on water like ducks. But what we can do is we can transfer over much of the existing neural network weights, the kind of the knowledge that it has inside it, into another model, slightly kind of what we call fine tune that second model. And this technique actually works great. This is, again, thanks to grad students who spend time experimenting and trying new things. They were able to find out that, hey, we can actually move things from one model to another, right? Like I can't easily do that in that housing example, but transfer learning with these large pre-trained like language, vision, audio models works really well. And you see lots of data science teams, this is where they spend a lot of their effort nowadays, is using pre-trained models and then slightly fine-tuning them for their particular task. So let me show you what I mean by that. If we go back over to the models page, this is where when you're working on a specific problem, you should take advantage of the hub to look for, hey, is there a model that solves my particular issues? Right? If you're looking around patents, hey, there's a ton of models here around patents, or maybe you're focused on biology, right? There's tons of on biology. I like to use the example of finance. So if we type in I know this one's called Finbert, which is a financial model. I'll see lots of existing models here. Okay. Lots of existing models here. Some that are what we call this transfer learning or finely tuned. So one of my favorites is this Finbert one here that's tuned on forward-looking statements. And the process here was there was an original model, a pre-trained model that was trained on lots of financial data, like all these huge 10K forms, like tens of thousands of all these forms. It understands finance really well, right? Because finance has a different vocabulary than if you look at, general, Twitter or Wikipedia information. So it understands finance very well, but then what they've done in this forward-looking statements is they've tuned this particular model here with a handful of sentences, right? 3,500 sentences to identify, hey, is this particular phrase something about the future or not? Because for financial analysis, it's important to recognize those types of statements when they're looking through forms, right? This has real kind of practical use for this. So you can see here's an example here. Is this something that's, forward-looking or not? Now, what we can do is we can take advantage of this model. I got a big button over here. I can hit copy and just literally copy the code so I can start to use this inside my notebook. And if I kind of scroll down here, you'll see I can take this code, literally kind of paste it in here. And now I'm doing the same thing as before, where I'm taking advantage of kind of this pipeline concept, but I've specified a specific model that I want to use. And so now this is the advantage of taking advantage of all those tens of thousands of models that are out there for that. If you're happy, if you're like, this is perfect, I want to put this into production, this deploy button here can help you with that. So one of the things that Hugging Face offers, and this is a commercial offering, is the ability to have an inference pipeline where Hugging Face maintains kind of the servers for your predictions, but you can get a quick kind of API. So you can kind of copy that off, go into your code, and then paste that in. And now, if you're working with your IT, if you're working with other folks, you can say, hey, here is my API. I need to just pass the data and I'll get back the results for that. And now we can start taking advantage of the models without having to maintain kind of our own servers along the way like that. Okay. So let's talk about, we're doing this Indian food, right? I need to build this Indian food classifier. I see the time ticking. Let's talk about kind of how I've done that. So what I've done is I've already done this ahead of time. I'll probably release a separate video on how I did this fine-tuned. But I started with that same transfer learning of a large pre-trained model, and then I tuned it slightly specifically with Indian foods to be able to build a classifier for that. So this is the model card that has that page. You can see one of the things is it links to that data set that I used here. I can go ahead and click and take a look at the data set. So here's the data set. I've uploaded it. It's freely available to everybody. I originally kind of went and grabbed it off Kaggle. You can see, right, as we go, it's got jalebi, we got pizza, fried rice, right? All this kind of delicious stuff, type of food here in this data set, images of. And what I did was I used all of these images and I trained my classifier to just detect these 20 different types of food, between these different types of food. I'm not going to discuss fine tuning kind of here. If you Google fine tuning, it's a fairly straightforward process to do. It's good to learn. But what I want to do today is just take advantage of this work that I've already done. So I've already spent time kind of finely tuning this model. I can, again, just click up here, grab the details about this particular fine-tuned model, go back into my code, and that's what's here, is I have the information about this model. Now, once I have this information about this model, I might want to test it, right? Like, okay, I built it there, it works in the browser, but like, I like to just double check this. So one way is you can try, let's reload the data set that it was trained on, right? There was a trained test partition. Maybe I'm just going to grab an image from the test partition. And that's what I do here is I go ahead and take advantage of the fact that that data set is on the Hugging Face hub, but I can use this data sets package as a quick way to be able to pull that down and to take advantage of that. And so what I've done here is I've pulled that down, grabbed the particular image from there. Then I've taken this image and then just run a quick, I've taken that image, extracted it, run it against my model. My model will give the results in 20 different categories. And so then there's a little bit of code here just to identify which category is the most frequent or the highest probability, and then what's the name of that. And that's where I get, hey, this is chai tea, like that. Some of you might not kind of believe it like that. So this is where, all right, what? Okay, hopefully I didn't run the other code, so that's why. Let me change this. I use the word model everywhere, so if you don't pick the latest model, it probably is what threw that off. This is what happens when I hurry and don't run the code as we go through this. Okay, there we go. Now it's working. If you want to just try this out for yourself, you can just grab any image as well. So you can see here, I put your code for if you want to just grab an image, and you can go ahead and get the class for that as well. All right. So hopefully this helps you understand how we're able to kind of take advantage of one of the finely tuned models and build on that. So got 15 minutes. I still want to cover some more stuff, but I want you to understand, hopefully at this point, you should know how to go to that Hugging Face hub, search for different types of models, test them right there on the page, be able to grab the code and build a simple prediction pipeline for a lot of different types of tasks. I've tried to sample a lot of different varieties here to kind of give you all of these pieces here. Okay. Now, I see a question about kind of finely tuned models. Now, what I've emphasized so far here today is using the existing models on the hub. It's quite easy to fine tune and build out your own models on custom data. That's a process called kind of fine tuning. If you want more information on that, we have lots of information on that. If you look inside the transformers, there's an entire section on here for kind of how to fine tune a pre-trained model. It's a very good skill to have. It's just a bit more advanced than I wanted to talk about today. Okay, we're going through. I see kind of questions. I'm trying to install questions as we go through this. So we've built out some cool stuff here. The slides here, if you look at the top of the notebook, you'll see there's a little thing where the accompanying slides are. Once I'm done, because I always change the slides up until the last minute, and I might even update or kind of clarify something in the slides if need be, but then I will drop them into my GitHub repo, and the link here will be updated to that. So just check the notebook, and you'll be able to get a link to the slides as well. All right. So we've built out some pieces of the model. I've showed you the code for doing the translation. I've showed you the code for being able to identify the images. What's next? And the last thing is, this is something I actually feel very strongly about. I make TikToks, and I made a TikTok about this just last week as one of my data science hints, is building web apps. Models are great. Notebooks are great for data scientists, for building out things. But if you have to explain what you're doing to someone else, if you have maybe a business partner that doesn't know data science, you have managers, you have C-level executives, they don't want to look at notebooks, right? They need an easy way to understand what you're doing with the model. And this is where I'm a big fan of having data scientists build web apps because they allow everybody to start using your model. And one of the great things is when you start letting those people start using your model earlier, you quickly figure out what are the limitations, what are the potential issues, what am I doing wrong with this? Because rarely do you build something like in the lab that 100% works in the real world. There's often some iteration, some changing that you have to be aware of like that. All right, so let's spend a few minutes here kind of understanding how we can all build web demos. It's not hard to do at all. So in the last part of the notebook here, I have how we can take these different models that we built and start putting them into a web development framework. Now, the web development framework I'm using here is something called Gradio. There's other fine web development frameworks out there. I started off as an R user in Shiny. Right? Streamlit is another well-supported approach as well. But Gradio is really designed for building simple web apps. All you do is tell it what kind of input you have, what kind of output you have, and how you want to transform that input to the output. You don't have to worry about building UI interfaces or doing any of that stuff. You can see here's a simple example of this, where we have a simple function that just takes a name, adds a little bit of prefix and suffix into it. The code for this is I just use the interface class. I tell it the function, right? The thing that's going to change the code. What do I want my input to look like? What do I want my output to look like? And that's it. And now I can, type in my name here. And I have a simple web app that I give it an input. It transforms that output like that. I don't have to worry about building the hosting infrastructure, the UI, all of that stuff is taken away for me. Now, that's cool, simple input and output, but what is the Gradio team is part of Hugging Face. So they've actually made it very easy to integrate in the Hugging Face models with this. So take a look at this. This is literally one line of code because they took one of the existing models that were out there. You can click on the link to see what kind of model, but they were able to build this simple interface where now I can say, hi, I am a robot, submit that in. And I don't know if the audio will, there you go. I don't know if you heard that, but yes, it works like that. Again, very kind of simple, quick way to do this. We're finding this very popular with kind of people that are developing ML skills or people that want to show off. A lot of conferences now, the latest computer conferences are having their people, when they publish their papers, hey, publish a web app that shows how that model is being used along with that. Now, I'm going to save you the pain of me walking line by line through this code, but this is the code for building out a very simple version of that application that I showed you for taking an image, identifying that image, then taking that text and then moving that over. I'll show you the actual spaces again, but I wanted you to get started with this. I've commented out the translation piece so that way you can kind of just first understand how the image part's working, and then you could go ahead and build out that. And you can see here, I have kind of the image piece working, and I can take an image, drop it in, and recognize that as well, right? Potty period. Okay, so let's walk over. I'm going to walk over and kind of show you the app that's actually working. Now, what I've done in this case, I think I have the link at the bottom here. What I've done with this final application is you can use Gradio inside your own environment. You can host it on your own. But Hugging Face has this spaces area that will let you publish and host your machine learning apps for free. So you give us your code. I don't know how we're going to pay for the bills on this, but we're going to host it for now for free like that. So you can see here's my particular app. I can kind of go ahead and kind of pick the food that I want, right? We understand that, hey, this is that image classifier that's running inside that I spent the time fine tuning and creating that. That's what's doing that recognizing. And then to do the conversion, I can pick a kind of a language that I want and do the translation. And what's running behind the scenes here is that Facebook kind of NLP model that's doing the translation. Inside the spaces, you'll see it even kind of shows you the linked models that's running. Beyond that, if you want to see my code, right, it's right here under files. And this is, again, freely available. You can all go, and I encourage you to steal from me. This is one of the great things, and I'll show you the other spaces in a minute. But you can see exactly how I coded up this final version and use it. I think one of the biggest things when you're starting data science is to learn, don't try to do things all yourself entirely. Go look and see how somebody else has done it. You know, borrowing and stealing code like that is entirely acceptable and okay, and how most of us learn quite a bit. Yes, sharing builds a much better world like that. I'm getting near the end here. So this is the spaces for this one. But the other thing I want people to recognize is if you go to the spaces, this is a great place to be inspired. There's so many cool machine learning applications here, and all their code is available. Like, I'm just clicking on this first one, right? Like, here's a demo that, you know, for mobile vision transformers and deep lab. I mean, I have no idea what's going to happen here, right? We can run this. You can see exactly kind of what it's doing. But if you're like, hey, how is this working behind the scenes? Go over here into files, take a look, and you can see the exact code that was used for it. You can cut and paste, use this code. You can clone these repos as well. And there's lots of spaces. I can tell you, you know, like I built, you know, ones for like forecasting as well. Oh, yes, you can see here as one when I first started, before I even started playing with the Hugging Face, I was like, hey, can I build something with just a profit time series library? Of course, you can host that stuff, host the data sets all on the hub. You can build that stuff out as well. So take advantage of spaces as another place to be kind of inspired as well as kind of share your own work. All right. Let's answer some kind of questions now, if that sounds good as well. What's the best way for me to do this? Should I just pull these up and kind of go one by one, or is there somebody read them to me? Or
yeah, we can have the questions from the attendees.
Okay, I see the open. There's 18 open answered questions. I'll go through these as I can, and we'll see what else.
Yeah, sure.
There's a question asked. I don't know if does this show up on my screen if I put it like this? Is this okay? Is there a difference between the Hugging Face and other face detection APIs? So Hugging Face is a generic place to show lots of models, right? Some of them are image models. Some of them, and I don't even know, there could be a particular face detection model, but it's just a general approach towards it. You'd have to compare that specific model to see, hey, is there a face detection model versus that face detection API like that? Explainability, Akash asked about, you know, how can we make pre-trained models more explainable to perceive the output? Explainability, bias, ethics, these are large issues that I haven't talked about, right? Like, what's the data that's going into these models? Do we really understand what do we understand what's going on to them? I think one of the things the team is doing is building out some better tools for helping us understand what's going on in these understand what's going on in these models. One of the things, though, we have recently added is, although it's not explainability, it helps us evaluate the models. Is for all the data sets, you'll see this evaluate models button. And what we can do is we can evaluate all these models on particular data sets and then be able to show them on this leaderboard. And this helps us go through and see, hey, let's make an apples to apples comparison to see, you know, I want to look at these kind of this data set on Amazon reviews, and now I can compare different types of models and see how well they do. So it doesn't necessarily get at explainability, but the first step is we want to understand what are the trade-offs of these models as well. So Gradio you can use for mobile, you know, on mobile devices as well. There was a question about kind of mobile apps, but that's as far as I know. It's also an open source project, so feel free to kind of jump into that. There's a ton of different models out there for things like, I think there was a question about, I want to use this on edge devices. There's a lot of different models on the hub, and this is where you just have to kind of dig into it and see what is the latencies for different types of models. Like we just saw that example of mobile vision transformer. I have no idea if it really will actually run on a mobile device. This is where you need to kind of spend a little bit of time trying it out on your own. Can you upload your own custom model on Hugging Face? Yes, please do. One of the great things about Hugging Face is it's a community. It brings us all together for different data sets that you have. Feel free to put them up there and share them for different models. If you're working in an organization that feels like, hey, this particular model or data set, we don't want to widely share with the public, it's possible to create private models, private data sets, private organizations on there as well. But we all can benefit if you can make it public. So yes, absolutely. Make it public and then make a spaces that shows off your model. That's the coolest thing. Let's see. I think there's some questions about kind of fine tuning. I think we should do some follow-up ones on those. We can do that as well. If you want to get more, there were some questions about like transformers and transformer architecture. One of my favorite ways for people to get familiar with transformers is there's a course. It's a self-paced course. It's really fun. It's a lot of kind of short videos that walks you through this, even has a little quiz to make sure you're doing it. This is a great way to kind of make sure you understand the basic concepts and how to use transformers as well. All right. I can talk forever about this stuff, but I want to respect kind of the time here. I hope you've all walked away with the ability to at least understand the crazy amount of cool different pre-trained models we have out there and how it's not too difficult to start actually using them for your own applications. I'll update the notebook with the slides for that. This is one of my first talks since I've joined Hugging Face. So please share feedback with me, either directly to, I don't know if there'll probably be a rating things and comments things on the seminar. Feel free to contact me individually. I spend a lot of time on LinkedIn. You can find me on LinkedIn at Registics. I also enjoy making TikToks. I make a ton of fun TikToks. You can see me at Registics on there. And then I'm a little quieter on Twitter and Medium as well. But I'd love to hear from you. So feel free to kind of reach out from me. All right, everybody. Thank you all for joining today.
All right. Thanks a lot, Rajiv. On behalf of Analytics Vidhya, I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.
Thanks.